Alrighty, good afternoon, good morning, good evening, whatever time of day it is you're watching this. This video is going to be a homework help or a project help for the missing money assignment, the assignment where you have to try to figure out which money is missing from the pot. And just like previous homework help, I'm not going to give you the answer, but I'm going to teach you all of the things that you need to know to be able to do this problem. You just have to put them together in the right order. All right, so in this problem, we have a list of lists. And in this list of lists, each individual list, each list within the larger list, has a text portion, a string, and it has a numeric portion, a float. And so to do this well, to do it through a function, which is part of the assignment, we have to be able to accept the list into our function, and we need to extract the numeric information from the list at one point and subtract the string part of the list at another point. And there's a few different ways we can do it, but there's one that's probably better than the other. So I'm going to set this up in function format so you can see passing the actual values and everything. So I'm going to just call this function missing because that's the assignment. And missing is going to take, in the assignment, it's actually going to take two parameters because there's two pieces of information that you're going to need to pass to it. One piece is the list of lists. The other piece is how much money was actually collected. Now, from that information, you can solve the problem because what you can calculate, or what you need to calculate, is how much money was supposed to be collected. And then you can find the difference, and then you can start to figure out which three items put together make up that missing money. All right, so the two things we're going to pass to it are a list and a float. And we're going to pass those two pieces of information. And in this case, we're going to pass this list X, and I'm not going to worry about passing I'm going to pass a float, but I'm not going to do that much of the problem for you. You hopefully can figure out how to pass the float and use the float in the way that you need to. So, but I do need to create one because I can't run the sample without passing one. So I'm going to pass that, and I'm going to make it a bigger number. It doesn't matter at all. I don't know why I made it a bigger number, but there you go. So we're going to pass the list and we're going to pass the float, and we are going to do a few things. And the first thing we need to do is extract these totals from the list. Now, you could use index numbers, but that's the hard way. The easy way is to use the for loop. And if normally we would use the for loop like this. So for items in X, print items. All right, or actually I'm not going to call it X because that might be confusing. Or actually I'm not going to call it X because that's wrong. In fact, it's going to be for items in the list, print items. Okay, so here's what we're going to do. We're going to just call this one thing right now. We're going to call missing, and we're going to pass to it our list and our float, which does nothing, but let's run that. All right, so that extracted the individual lists, and we could use an index number now to extract the part we want. We could have said print items dot. Now here's where it gets difficult. So I guess what we would have wanted was items index position 1. So I could have done that. But again, I'm going to tell you that's not the best way to be doing this. So you will see that that did in fact pull out our floats. And there's something else about these floats that I need to point out to you in a minute, which might cause you problems as you actually run the assignment on the larger list. And so you see it did extract that item, but that's not the best way to do it. There's a far easier way to do it. And what I'm going to do is I'm going to extract the string item and the float item from my list, and I'm going to print the string item. And you'll see when you have a list of lists, if every list in your list of lists has the same number of elements, or this actually works for a list of tuples or a tuple of lists or a tuple of tuples, it will work in any of those cases. And it'll work if they have 3 items or 10 items or whatever. But if you specify an item for each item in the list, you can pull out the individual pieces. So you'll see right now that if I run this, I got just the strings out of it. If I asked it to give me the floats by pulling out the second item, you'll see I get just the floats. So the nice thing about that is, since I need to, for this problem, pull out the floats to find out who is missing, and then once I find out what string is associated with them, by doing it this way, I can do all of that at once. So you're going to use a for loop that specifies multiple individual items that are part of the iterable item. So in this case, when I have 2 items, the first one refers to this, the second one refers to that. All right, if I only put 1, then it's going to pull out the entire, each individual mini list as the item. But if I specify 2 and there's 2 in the list, it will pull out 2 like that. Hopefully that makes sense. All right, so that's thing number 1 that you have to remember. Thing number 2 is that you can embed a for loop inside of a for loop, and the for loop within the for loop can actually be iterating over the exact same list. So I could say for string item 2 and FL item 2 in a list, print str item, comma, str item 2. Now here's what you're going to see happen when I run this. It's going to iterate through this list first, the list number 1. And the first item is A. All right, so string item 1, or str item, is going to be the A. And then it goes down to this list, and the first item in this list is A again. So it's going to print out AA. The next time through, it's going to iterate through the inner loop first, so then it's going to be AB, AC, AD. Once it gets to D and this list is exhausted, it goes back up and goes to B. And then it drops to the lower loop, and I will get BA, BB, BC, BD. And then the list is exhausted, so it comes up, and then I will get CA, CB, CD, CC, CD, and so on. So go watch this. So I have iterated through every possible combination in my list. All right. And what I could have done, if I'd really wanted to, is instead of iterating through like that, I could have said to print FL item plus FL item 2. Now, that gave me each pair added. So the first one was $1.02, $1.02 and $1.02 is $2.04. $1.02 and $4.35 is, wait a minute, it is $5.37, not $5.36.9999999. Okay, weird thing about floats in not just Python, but other languages too, but in Python in this case, is a float is designed to represent a floating point number. So it's designed to represent, 3.45 times 10 to the 21st or whatever. And when it does that, sometimes when you have addition in here, you discover that you end up with rounding issues. So in order to avoid rounding issues, what we can do is we can say round, because usually it's going to be at 10, 12 decimal places, so it's very, very small. But of course, when you're trying to compare compare, if I can remember the right number of parentheses here, when you're trying to compare this to what you expect, it's not going to match. So if I was looking for when it hit $4.37, I would never get $4.37 because of the rounding issue. So just to be careful, I'm going to use round. And the format for the round function is round, and then a float. Or, it could be an integer, but that would be kind of pointless. And then the number of decimal places that you want it to round. All right, so I have round, and in this case I have a more complex, I have I could have added them and then rounded it, but I just saved myself a step here. So now if we run this again, I get my nice round numbers. And so if I was looking for 537, I would find it. And interesting thing, you're going to notice that I'm going to find 537 a couple of times. That I am in fact going to find everything a couple of times. And that is because, keep in mind that it treats AC and CA as kind of the same thing. So here's the next thing, and this is a computer optimization issue more than it is really is a necessity. So if I decided that I wanted to find the combination that made up $9.63, I could say something like this. I still need that. Yes, I do. Okay, sorry, I'm making sure I temporarily lost my head about what. Okay. I could say something like, if, I'm going to actually make this into a variable, so I'm going to say, I'm going to give it a different total equals, or tote equals that, and I'm going to say if tote is equal to, what did I say, $9.73, print str item plus, no, not going to use concatenation here, str item 2 equal 973. Oops, forgot my quotation mark there. Okay, so now when I run this, I knew it didn't look right. What did I do wrong here? I guess this does not need to be in parentheses, and actually if that's not in parentheses, then that's an extra parenthesis. All right, let's try that. Okay, so I get two answers, and it's the same answer. It's B and D. So we could do that, but I don't think that's clean. So to clean it up some, I want to avoid the duplication, and there's a couple of ways to do it. And one is a really complicated way where I could put in a flag and I could say, as soon as you find something, run that flag and then break out of this loop and don't print anymore, or all sorts of fancy stuff like that. But here's the other thing I can do to get out of it. And the reason I don't want duplication is twofold. Number one, I don't think it looks good. But number two, and here's the big one, this is a very short list and it can iterate through this list very, very quickly. But what if I was checking 5 values and instead of 2 here or 3 in your assignment? And what if there was 1,000 choices for each one? Well, that's 1,000 to the 5th possible combinations. And if I find it on the second iteration, then I'm iterating through 1 million or so combinations that I didn't really need to go through. So I want it to stop as soon as it finds the first match. And if you're not in a function, there's not an easy way to do that. But if you are in a function, there's a very easy way to do that. And the thing is, in a function, and this is a void function, this is not returning any value, but we're going to make it a function that returns a value. And so instead of printing out that result, I'm going to say return string item 1 I'm going to make them into a string. I'm going to return string item 1 plus, make a space. All right, and then I'm going to say, I don't know why I chose v equals missing xy. So what it's going to do is when it finds a combination, it's going to return the string to my function. And then, so if we know that it's b and d, what it's going to return to my function is b and d. And so v is going to become equal to bd. So I can then say print b equal 973. Oops. All right, so let's try that out. All right, so now I got b and d equal 973, and you'll notice I didn't get also d and b equal 973, and that's because the first time it found a match, it returned the value to me. And in a function, as soon as you see a return, the function stops running. All right, as soon as you get your first return, the function stops. So as soon as it found a combination, it returned it to me, and it didn't have to go through all the other iterations to go through it. And I could demonstrate this on a much larger list. And in this list, it only saves you 10 or 12 or 15 or maybe even less computer cycles, calculations. But in a really, really big list or a really, really deep check where you're checking for 5 things total to make something, that would make a big difference. All right, so basically what you need to do to solve this problem is you need to extract these to get your actual total pledged by all of your people. You need to subtract out how much you got. And you're going to do that in your function by iterating through this and totaling them up, subtracting how much you actually got. And the difference is what you're looking for. And then you're going to loop through your list on 3 occasions. You're in 3 nested loops so that you're getting every possible combination of those 3 items. And as soon as you find one, you're going to return who it was that is associated with those correct amounts. All right, one last thing that you could do, and I did it in mine, and when I demonstrate mine to you guys, you'll see that it actually saves a lot of iterations. So this list, we don't need AA, we don't need BB, we don't need CC, we don't need DD. Those are duplicates, right? And one person can't not give money twice. So what the first combination we need to check is not AA, but the first combination we need to check is AB. We can make it start our list at index position 1 like that. So now it's going to check AB, AC, AD, then it's going to check BB, BC, BD. Okay, you still get duplication, but it does cut down, and we could get a little fancier, and even if it were a really long list, we could get fancier and we could cut down a lot of iterations. But that's really not necessary in this problem because we're not talking a huge number. In computer terms, it's not a huge number anyway, so don't worry about that. But I just wanted to demonstrate that is another way you could have optimized it just a little bit. All right, so hopefully this gives you everything you need to know to solve this problem. If not, make sure you get in touch with me and I'll help you.